ABM mask aligner. This system comes with a 500 watt UV lamp power supply, and the system is capable of handling up to 8-inch wafers. Currently set up for 6-inch wafer, and it has a microscope with a split field objectives. There are 2 cameras on the system and 2 monitors for viewing the alignment marks on the sample. So the system will be shipped with the mask holder removed. This is a 7-inch mask I have, and this mask is not held under vacuum. Instead, it is mechanically clamped using 4 brackets, and the mask is held under the brackets, and the whole frame, the mask holder frame, is mounted on this mask frame, and which is pneumatically operated to raise and lower it. So when we lower it, there are 2 vacuum cups on either side of the alignment module, and the frame will be held under vacuum for stability. So there are 2 thumb screws to hold the mask holder, and the frame is lowered, and there are vacuum lines holding the frame in position. This system currently is set up for 6-inch wafer. I have a 6-inch wafer here, and there's a substrate holder on the chuck. The substrate holder is held using 2 thumb screws, and there are 3 lines under the substrate holder, 1 for the contact vacuum, so these are the vacuum lines here. The BL is for the ball lock, and this is for the substrate vacuum, which holds the substrate on the vacuum. And the contact vacuum, the vacuum is released through the gasket, so that there is a vacuum generated between the substrate top and the bottom of the mask. And this seal is important here, and without the seal, the contact vacuum is not achievable. So this is a silicone gasket, which is of the order of thickness of about 0.015 inches to 0.020 inches. So it's a very thin silicone gasket, and I will include the dimensions of the gasket in the manuals, just in case if the gasket needs to be replaced. It is very simple. Using a gasket cutter, we can cut an annular shaped gasket. So there is a O-ring here on the substrate holder chuck, and this is very important because there's a substrate vacuum goes through this, and it needs to be sealed on top of it. So this is first. And there's also another line here which is for the mask vacuum. So sometimes the mask is held under vacuum, and at that time this line needs to be connected. And the mask vacuum is enabled using this button switch. So you push it in to turn it on. So all the pneumatic controls on this mask aligner or mechanical or pneumatic switches, So I'm going to connect contact vacuum first, then the substrate vacuum, and then the ball lock vacuum. So what the ball lock vacuum will do is the top plate of the substrate holder is pivoted, or it is on a ball. Under vacuum it is held in a position so that when the chuck is raised up using this knob, by rotating this one counterclockwise while holding the ball lock vacuum down, so the ball lock vacuum push button here releases the vacuum and we can move it if we, and you will lock it in that position, tilted position. And then the first time, every time a sample is loaded, so first load the sample and turn on the substrate vacuum, and there are vacuum gauges for the system vacuum, and we have substrate vacuum, mask vacuum, all are 0 to negative 30 inches of mercury vacuum gauges, also contact vacuum, and there are flow meter for nitrogen and pressure gauge for system pressure. So once we load the sample and lower the mask frame, press the ball lock release and raise the chuck up. So usually we have to raise it till we see that the substrate comes in contact with the mask. And if we try to raise it up further, we'll start to lose the system vacuum or the mask vacuum if there is a mask vacuum connected. So right now the substrate vacuum is about so once the substrate comes in contact with the mask, then this knob can be rotated clockwise to lower the chuck. And there's a scale here. Each increment equals 12.5 microns. So we have to keep an eye on how many counts we are lowering it down. So it's marked in even numbers. So I'm going to demonstrate how the contact vacuum takes place. So we have lowered the chuck, and these knobs are for moving the substrate. So unless there is a gap between, you have to go lower the chuck for a known amount of distance, and then we can move the substrate easily. Attempt should be made only to align when there's a gap between substrate and the chuck. So once the alignment is completed, we have to raise the substrate again, and now I've turned on the contact vacuum. So there's an adjustment knob here. We can increase or decrease the contact vacuum. A typical hard contact will be about 20 inches of mercury. Right now it is 22. I can reduce it by adjusting the knob here. Also, when we want to release the contact between the substrate and the mask, we have to turn off the contact vacuum and turn on the nitrogen pressure so that nitrogen gas is purged between the substrate and the mask. Sometimes it will be ideal also to lower the chuck. So then we can release the mask frame, and I'm going to unload the wafer by turning off the substrate vacuum. So this is the arrangement for 6-inch wafer. I'm going to do it one more time. I loaded the wafer and then lower in the mask frame. Now for alignment, use the pneumatic switch for the microscope. Located it on the alignment module, and there are 2 buttons on the arm. You press the button to release the table. The microscope table can be moved in X and Y direction, and there are the objectives can be located by using the turn wheels here. We can move it to the point where we want to move it, and there is also a knob for adjusting the height. And these are the zoom in knobs here on the objective itself. In order to prevent pre-exposure of the photoresist, yellow filters are used in the fiber optic source pad. There are 2 fiber optic sources which are illuminating the sample. So once we locate the sample on the, so I have a mask with some spiral pattern on it. So these are the patterns on the mask. So once I'm moving the substrate, you can see it is moving in x-axis and y-axis, and there's a third knob for theta for rotating. So this is the alignment part. Once the alignment is done, we raise the substrate and turn on the contact. And in case hard contact is not desired, we can reduce the contact vacuum and bring it down to 10 inches of mercury. And then once we have established the contact, now we have to move the alignment table away from the aligner, and now the light source can be moved to exposed position. So before moving the light source, the lamp power supply is here. I have turned it on and it is at 500 watts, and it can be operated in constant power or constant intensity mode. So in constant intensity mode, there are 2 channels, A and B. Each channel can be set for either 365 nanometers and 405 nanometers. And then by adjusting the cal pot, we have to this meter, the power and intensity meter, also will display the energy level in milliwatt per centimeter square. Using an external meter, using the we can calibrate this meter to read the energy at the exposure surface by adjusting the cal pot. And then by setting the set knob slightly, at the desired energy level, we can obtain the required energy dosages. So right now it is in constant power mode, and in order to read the intensity, the shutter should be open. Let me quickly open the shutter and show you. So right now I can read the intensity. So the detector, the channel B is reading that much, and channel A is also reading. So these pots have locks. We can calibrate it by adjusting these pots. So like that, I'm able to calibrate it. So that's the intensity. So we have to put it, once we put it in constant intensity mode, the intensity will be controlled by the power supply to the desired energy level, whatever we set using the set knobs. So there's another meter here which displays the amperage and the voltage of the lamp. So it's very easy to start the lamp, turn on the power and press the start button to ignite the lamp. And then typically the power supply requires about 15 to 20 minutes of warm-up time. So once the lamp is set up, we set up the timer here, this Omron timer here, and then we can verify the timer is good by using the auto exposure button. So at any point of time, if we notice the system vacuum is dropping below 20 inches of mercury, or any of the vacuum gauges show abnormally low value, then there is a vacuum leak in the lines and the problem should be rectified. So I have verified the timer, and now I'm moving the light source to the exposed position. As soon as the light source comes to the aligner module, the timer kicks in and the exposure will take place. So I have a 405 nanometer detector here. At 405 nanometers, it is displaying about 19.5 milliwatt per centimeter square of energy. So after the exposure, the light tower remains on the aligner module, and so then we have to move the light source to the home position, then only the sample can be removed. Before removing the sample, turn off the contact vacuum, turn on the nitrogen, and lower the substrate, and then lift up the frame. Now, since this system is required to operate for two other kinds of samples other than 6-inch wafer, I'm going to demonstrate using a 4x4 substrate holder. So I have a sample simulators here. This is a 5 millimeter thick 2.5 inch by 2.5 inch plexiglass I made, and this is a 100 by 100 millimeter, about 6 millimeters thick plexiglass plate. So I'm going to show how to use these. So these are thicker than the standard silicon wafer. So in order to load this, so I have marked again the vacuum lines here. There's a contact vacuum, substrate vacuum, and this is the ball lock vacuum. And typically when a regular, almost like a 1 millimeter to 500 microns thick samples are used, there's a square gasket that goes in the groove, and this chuck can also generate contact vacuum. But since we are using a thicker sample, this gasket, the advantage of the contact vacuum cannot be taken. However, we can raise the chuck and get a mechanical contact. Usually the contact is viewed by using a sample like this. When it comes with a transparent mask in contact, we can see Newton's rings patterns. So I'm going to show how it looks. If we have a patternless wafer, we can see some fringes on the substrate when it touches the mask. So I'm going to replace this substrate holder. So this is a round chuck of 6-inch wafers. So this is also exactly similar mechanism. First make the contact, substrate, and the ball valve. So after connecting all the vacuum lines, make sure the thumb screws are tightened, the substrate holder fully down. I'm pressing the ball lock release and I'm able to move it, otherwise I can't move it. So let's start with so before I do anything, since it is a thicker wafer, I have to lower the chuck all the way down and there's one more thing I have to do. This is a 7mm thick wafer, so I have some spacers that has to be placed on the frame. These are 2mm thick copper seals which I stole from another application we generally use, but these are good. Once we place them in the center of the plate, and now we can, so wherever this mask holder is placed, it should be evenly touching you have to make sure it is not tilting or wobbling. So now I have my mask frame in place and it is held by these thumb screws. So I have this sample here. Turn on the substrate vacuum, I cannot move it, and then I lower the frame and once again release the ball lock, and so I'm raising up the sample. We have to make sure that we are not trying to push the whole frame up by rotating this. So I have some numbers that I have written down in order to do this. So now once we are fully in contact with the can you capture the rings there? There are some circular rings at the center because I'm rotating the knob and I can see the Newton rings formed between the shining substrate and the mask bottom side. So this is for the 7mm sample. So I'm going to lower the sample and raise the mask frame, release the substrate vacuum, and then I'm going to put the 2.5 by 2.5 sample. So I remember this sample uses a different so there are holes here under this top plate. By removing these 3 screws, we can block the openings on the ends and get a better sample vacuum. So since this sample is smaller, I get a substrate vacuum slightly lower than 20 inches. So I'm going to So I had to change the mask holder for this sample. So this is a 7 by 7 inch mask holder. So this is my 5 inch mask holder. So this is a mask vacuum connector. So I'm going to. So this one has both vacuum as well as mechanical screws to hold the mask down. I'm going to connect the mask vacuum line and enable the mask vacuum and pushing it. So right now, for this 5mm thick, we can remove one of the copper rings, the spacers. Even without it, we can use it because see, once we go too high, the substrate starts to push the mask and I can hear the vacuum release. So once I push the button and raise it up, now the substrate is parallel to the mask, and now then we do the alignment and do the exposure. So this is a quick video demonstration of all the 3 samples and the 2 mask holders. The system requires a 4-inch exhaust line for the lamp housing cooling here. I'm using in-house vacuum line. And it requires a vacuum pump for generating at least 25 to 30 inches of vacuum. We can also use a low pressure nitrogen, about 10 to 15 psi nitrogen. And the compressed air required is about 40 to 60 psi pressure. So I will also now show the energy level. So I'm going to show you the energy level at 365 nanometers, which is about 5.9 or 6 milliwatt per centimeter squared. This energy level is with a 500 watt lamp. And the final length on this lamp housing is almost 9 inches in diameter, so the energy density is reduced because of that. And also there are aperture controllers here. We can increase or decrease the aperture control on the cameras. And when we ship out, these fiber optic sources will be removed from this, and every moving part will be tied down so that in the shipment there won't be any damages to the moving parts. Even the monitors will be removed from the table here, and the lamp will be removed from the lamp housing, and the lamp direction of installation is marked on the lamp housing. So anytime a lamp is changed, the upper door can be opened and we can access the knobs to locate the lamp position in X and Y directions, and there is a chain which we can rotate The chain is rotated by this knob, and we can focus the lamp along the vertical axis. So that the arc in the lamp is at the focus of the ellipsoidal reflector. These ellipsoidal reflectors are available in California from Optiforms, and the lamps are available for Advanced Radiation Corporation. I will include their website details in the user's manual. And while the lamp is on, no attempt should be made to open this lower door, because severe radiation, exposure to UV radiations will happen and cause some damages to the user. I have a 4" by 4" sample with a chromium plating on it. It is a 4" mask actually. I'm going to use this as a sample to demonstrate how the alignment looks like on this system. So I loaded the sample with the pattern up, and then lowering the mask. So I have this I have to remove one of the spacers. Even both remote it should work. So the thickness of the sample here is about 2 millimeters. So I'm going to show the on the objective, this is the bottom knob is the focus knob, and we can focus it on the sample. You can see the sample beneath moving. So you're able to see the pattern on the sample here. And then there's another knob on the top. We can zoom in to and we can zoom into the whole image and magnify the image. So after magnification, sometimes it will be necessary to refocus it. And then we have to bring closer the sample closer to the mask, and then lower it by about 2 divisions. And so if you go too high, too much down, then the sample may not be focused. But here we have good amount of. So right now it is focused on both the sample and the mask. And also we can bring these two microscopes close enough by orienting these barrels in such a way that there's no gap between these brackets, and the closest they can come is less than a couple of inches. So in case if the sample is very small, then we have to rely on one of the microscopes and move it using either the joystick or these fine adjustment wheels, and locate it at 2 different alignment modes and align it.